is the probable bond energy of the O double bond if the combustion of C2H2 is 1,259 kJ per mole. So since we're given the enthalpy of combustion, this will be the equation we use because we're asked the bond energy and the enthalpy. Now the way we set this up is the bond energy of the bonds that are broken minus the bond energies that are formed, because when you break bonds, it's endothermic, and when you form bonds, it's exothermic. So the signs work out. So in other words, this side's going to be the reactant, and that side's going to be the product. So this is number one easy mistake. Number two easy mistake is when you put in the enthalpy here. You notice how it's kind of like a trick question because they wrote it's endothermic, but it's supposed to be exothermic. So that's an easy mistake number two. So this is going to be exothermic because it's combustion. Now we're going to throw in our values for BE, but first we'll set up the equation. Right, so there is going to be 1 times the bond energy of a CC double bond and 2 times the CH bond plus 5 over 2 of, this is what we're trying to find, so I'll write X. And minus, now this is another easy mistake. I've made this error many times. Notice how there's 2 bonds, right? So you write 2 bonds. But then notice how there's another coefficient there. So then you want to write another 2. So that means this is a 4. So this is 4 times a CO double bond plus 2, okay, 2, and then to a coefficient of 1. So it'll just be 2 times 1, 2 times the bond energy of the O and the H. So that will be the way you set up this equation. And if I plug all of the numbers in correctly, we're going to get something like negative 1259, 2465 plus 2x. Okay, so then in that case, the final answer is going to be something like 1206 divided by 5 over 2. So X, which is the approximate bond energy of O, is going to be around this much kJ. All right. Now, big takeaways. Number 1, when you're writing this equation, make sure to set it up in a way where your reactant is minusing your products. Second thing is, even though they say the combustion is this many moles, you have to think combustion is negative. So please remember negative sign. They shouldn't even be doing this to you. And this third thing is, when you're multiplying by the coefficients, it's not just the coefficients, okay? It's also the coefficients times the number of bonds that there is. So instead of just looking, well, there's 2 on the right and there's 2 on the left, so that's 2. No, it's 2 times 2, so it's 4. And those are the big takeaways for a bond energy problem.